Good morning, everyone. In this lesson, our learning outcomes. At the end of the session, you should be able to apply the PCM process of sampling, quantization, and encoding. Sampling is a process of inspecting the value of an analog signal at regular time intervals. The time between samples is referred to as the sample period, and the number of samples taken per second is referred to as the sample frequency, Fs, in samples per second or Hertz. Take note that we have the Nyquist criterion that the sampling frequency must be greater than or equal to twice the highest analog frequency of a given signal. So sampling is just taking a sample voltage at regular time intervals. To illustrate sampling, for example, consider the following analog waveform. This waveform is sampled at 1000 Hz rate and quantized with a 3-bit quantizer. The input range is -1, so you have -1 and 1. Circle the sample points. So first, you need to solve for the sampling period. That is just the inverse of sampling rate, because period is inversely proportional to the sampling rate. 1/1000, so 1 milliseconds. It means to say that the sampling period Ts is every 1 millisecond. So every 1 millisecond, you need to get the sample. So you need to scale down here the voltage for you to easily identify the voltages. So you just write the scale. Then you sample every 1 millisecond. And then every 1 millisecond, you will get a corresponding sample voltage. And at time 1, time 2, 3, and so on. These are your sample voltages. So to illustrate further, you have the sample voltage for time 0 is 0. Create a table for sampling period and sampling voltage. For time 1 millisecond, you have 875. And then for time 2, you have 6875, and so on. Just complete the table for you to easily see the sample points at a particular period. Okay. So the classification of signal in sampling is it is a discrete time continuous amplitude. Quantization. Quantization is converting a sample value from the set of infinite possibilities to one of the finite set of values. Is called quantization or quantizing. These values are referred to as quantization in levels. To illustrate quantization, for example, you have here the result of after sampling. So you need to create, you need the help of a table in bipolar table in quantization. It is divided into 3 columns for binary code, quantization level, and input signal voltage. So it means to say after your sampling, the voltage levels here have infinite values, possible values, continuous amplitude values. So it means to say in quantization, you need to divide the sampled voltage into finite number of voltages. So first, you need to get the M for the given M is 3 bits. And then it means to say the number of levels for this sampled voltage to be divided is 8 levels. So that is 2 raised to 3 levels. That is 8. And then you need to solve for the resolution. Resolution is the number, the amount or the value of steps per levels. So if you have 8 levels, what is there? What is the voltage that separates per level? The amount of voltage separation per level. So that is resolution. So for this example, they have 0.25. So every level has a resolution of 0.25. Okay, and then resolution is voltage steps per level. Okay, so applying delta here to the table. So we have delta here, substituting delta to the table. So you will get these values. It means to say that for the range from -1 to -0.875, the quantization level is -1. So any voltages, sampled voltages that falls within this range will be given a quantization level of -1 and also a binary code 000. And if a voltage, for example, fall here, it will be given a quantization level and a binary code. So as you can see, the sampled voltages will be grouped into range, and it will be divided into 8 levels. That is depending on the number of bits you have. So for 3 bits, there are 8 levels, and those sampled voltages will fall in these levels only. Okay, so to illustrate, if you have a sampling period at time 0, the voltage sampled is 0, so the quantization level is also 0. Why? 0, as you can see in the graph, 0 is found here. So it falls within this range, 0. So it will be given a quantization level of 0 and a binary code here. And then for sampling number 1, time 1 millisecond, the reading is 875. So 875 falls at what? Here. So it will be given a voltage of quantization level of 0.75. For example, at time 6, the reading, the sampled voltage is 0.25. So 0.25 falls within here, this range. So it will be given also a quantization level of 0.25. So 0.25. So that's the quantization level. So you get the sample value and then look for the range it belongs and then give that an equivalent quantization level. So that's the quantization. That is quantization. For encoding, encoding is assigning an equivalent binary code to the quantization level of a sampled voltage. So for example, you have a sampled voltages here from the analog signal. Then we already get the table by substituting delta to the table. You can get here. You can use Excel to solve faster, no? And then, so we have here the table. For example, you're just encoding means after you get the quantization level, that's the time you assign the equivalent binary code. So that is just that is encoding, assigning binary code to the quantization level. So for example, at sampling time period 0, you're 0, you have a sampled voltage 0 and a quantization level 0. So the binary code is that is equal to 100. And for example, at time 4, the sampled voltage at time 4 is 625. 625 belong here. So it has a quantization level of 0.75. So what is the binary equivalent? That's 111. So that is just encoding. After getting the quantization level, you give the equivalent binary code. Okay? Another quick method of getting the quantization level and binary code without using the table. For example, you have a sampled voltage and you don't need to create a table because it's time consuming. So one way to know the quantization level and binary code for that is that you need to solve analytically using I is round x minus x min over delta. So I means when you round off that number, your I from digital will be converted into binary. For example, you have, for example, x, your sample voltage is x is 0. For example, at time 0, x is 0. So if we solve for I, the answer is 4. 4 will be converted into binary. So 4 decimal is 100 in binary. And so as you can see, when the sampled is 0, the quantization level is also 0. We have xq. If you compute here, xq will be 0 and the binary code will be 100. So this is a quick method of getting the quantization level and the sampled voltage binary code for that sampled voltage using this formula without creating the table. So the table is for easy verification in assigning quantization level. This one is a quick way of getting the quantization level and binary code. So to finally illustrate the 3 steps, we have quantization error. The quantization error is the sampled voltage minus the quantization level, because when you are getting the sampled voltage, that's the exact voltage that falls in your sampling. But when you are quantizing or in the quantization, you have different values na for your sampled voltage. So there is now a difference between sampled voltage and the quantization. So sometimes the quantization falls below or above the sampled voltage. So there is now an error. So that error is what we call the quantization error, as you can see here. So for example, this is your sampling process. In quantization, you have an approximate values only. So for time 0, that's 0. Then for time 2, you have quantization level 0.75, so 0.75. So it falls short, no? From 875 sampled, it now becomes 0.75. So as you can see, it falls short, and so on. So yung sampling mo voltage and and your quantization level has a difference. So may error kasi hindi na exact yung nakukuha mo pag sa quantization. After quantization, you have binary code equivalent. So what will happen in coding is, at the exact period, you assign the bits, the 3 bits into the pulse na equivalent. For example, at time 0, that is 100, you just assign 1 and then off. Period, and then 111. So assign mo lang ng binary bit per sample. Dapat 3 bits per period. Yan. For example, dito dapat 101. So per period yung pag-assign mo ng binary. So that is encoding. So that is the process of sampling, quantization, and encoding. Okay. So quantization is you start from the quantization level and then go right. Start, for example, 0.75, go right. 0.75, go right, and so on. And then connect the dots to create a discrete